Okay, so for this question, we're going to apply exactly the same formula that we just looked at, but we're going to answer a question that's looking at the application of this in a slightly different way. For the last question, we had to figure out what our freezing point depression was. In this case, we're asked to find something else. We're asked how much NaCl must be added, and I should have specified this. How much NaCl in grams was what I was looking for. How many grams of NaCl must be added to 450 grams of water to make a solution that boils at 150 degrees C. So notice we're not dealing with freezing point depression anymore. Now we're dealing with boiling point elevation. So the big deal is, let's just write out our formula again. In this case, we've got our boiling point elevation is equal to our Van 't Hoff vector times our m times our k. In this case, it's kb. It's still water, but the freezing point depression constant and the boiling point elevation constant are not the same. For water, this actually is 0.512 degrees C kilogram per mole. Now this is still NaCl, so our I is still 2. Once again, our m is what we're trying to find. And if m is what we're trying to find, because our molality is what we're trying to find, because that's going to give us a way to get back to grams. If this is what we're looking for, then that must tell us that, well, if this is what we're looking for, then shouldn't we be given this? Because it doesn't look like we're given it. Well, the fact is we are given enough information to calculate what this is. It's all about how you read the question. So the solution boils at 105 degrees C. Now everybody knows that's not the boiling point of water. Boiling point of water, of course, is 100 degrees. So therefore the boiling point has been elevated by 5 degrees C. So therefore in this case our boiling point elevation is 5.0 degrees C. And that's particularly important because now we can sub that in here. Alright? So we know we have 5.0 degrees C. Our I is 2. Our m is what we're trying to find. And our kb is 0.512 degrees C kilogram per mole. Okay, and then we can just rearrange our formula. And essentially what we'll say is our m is equal to this times this underneath all this. Okay, so let's just write all that out. 5.0 degrees C divided by 2 times 0.512 degrees C kilogram per mole. And now just one thing to be careful about as far as units go. Okay, we'd said on a previous slide molality is moles per kilogram. So we want to make sure that the units here that we generate are also moles per kilogram, because that will tell us that we have arranged our formula correctly. So our degrees C shouldn't be there at all. One on the top, one on the bottom. But then you might be wondering, well, I've got kilograms and moles on the bottom. How can that give me molality? Well, the way to think about it is, yes, these are on the bottom, but in a way they're on the bottom of the bottom. Alright? And so a way to get around the problem of these units, because these don't look, this looks like you got a fraction, then a fraction underneath it, which looks rather confusing. And what you'll have seen before in a math class, for example, is that when you have units like this, you just flip them in your answer here. So what that means is we get rid of our degrees C, we flip the moles and the kilograms, and we actually do end up with units of moles per kilogram, as we should expect. And when we calculate all that out, what we end up with is a molarity of 16.534 moles per kilogram. Now that's moles of NaCl per kilogram of H2O. Alright? Okay, so at this point we have a number of moles of NaCl per kilogram of water. but we still have to find a way to get to just grams of NaCl. I know we can go from moles to grams, but what do I do about this kilograms? Well, we haven't used this 450 grams anywhere yet. And so what we have to remember is we have 16.534 moles of NaCl in 1 kilogram of water. But of course we don't have 1 kilogram of water, we only have slightly less than half a kilogram. So we've got to take that into account when we calculate our moles. So therefore we've got 16.534 moles of NaCl over 1 kilogram of water. So let's take into account that fact. 450 grams is 0.450 kilograms of H2O, which actually allows us to calculate our number of moles, which in this case is 7.4403 moles of NaCl, because our kilograms and our kilograms cancel out. And then the very last thing is just a conversion from moles to grams. Okay, so we have our last answer, 7.4403 moles of NaCl. We're going to do just what we did last time. We know we have, in this case, 1 mole of NaCl on the bottom. We have 58.44 grams of NaCl on the top, and that gives us an answer, it's actually rather a large answer, of 434.81 grams of sodium chloride. That's what we need to do. So the point is here, you have this 4-component equation. This Kb is always going to be a constant, m is always going to be a variable, as is I, as is delta t. And really, you could be asked to find any one of these 4, provided you know the equation and how to use it. Calculating these things is really not that difficult. Thank you.